So what do you mean by sequential circuit? Sequential circuit means it is going to produce the output based on the present input and present state put. That present state I can call it as a memory, right? And we are going to have various kind of circuits are there. Among those, one circuit if we take as combination circuit, and it is going to produce output. This will be connected like this, right? And here it will be having a kind of clock signal, right? So we have understood the meaning of what is the meaning of a clock signal, and also we know the meaning of combination circuits also, right? You know the meaning of output, you know the meaning of inputs also, right? What you have to know here, you have to know how your memory is going to be implemented. Memory is implemented. So this is what I can call it as memory element, right? So meaning that basically in digital electronics we are having two types of memories. One is latch, another one is flip-flop. Latch, another one is flip-flop, right? So basically this latch and flip-flop are the two kind of memory elements which are going to store a single bit of information. Single bit of information, right? Single bit means it can be either a 0 or it can store 1, but not both at the same time. So, but it can able to support either 0 or 1. I can call it as bistable elements. What is the meaning of stability? What is the meaning of stable? Constant, right? Meaning that if I am going to give 0 as input, it is going to produce the 0 as output. That is what I can call as stability, right? Bistable means what? If I am going to give 0 as input, it is going to produce 0 as output. If I am going to give 1 as input, it is going to produce the 1 as the output. So these two are the elements which are supported by these features. I can call it as bistable elements, right? Basically meant for the purpose of storing single bit of information, right? So if it is going to store single bit of information, like for example, if it is stored with 0, I can store with a 0. For example, I don't want to store 0. Instead, I want to place some value like 1. I can able to place here, right? If I want to reset it, I can able to reset with the value 0. Meaning that on latch and flip-flop, we can able to perform various kind of operations. Like one can be a reset operation, one can be a set operation, one can be a hold operation. Like that, we can able to have various kind of operations we can able to perform on these kind of memory elements, right? So while going on the classes, you can able to clearly understood what is the meaning of all this. For time being, try to understood that these two are the bistable elements. Bistable, right? So here I am saying that if I am going to give 0 as input, it is going to produce the 0 as output. How it will happen? Is there any chance that it is possible? For example, try to observe, I am having a NOT gate. If I pass here 0, what might be the output you are going to get? 1, right? So can I connect this same thing to one more NOT gate? What might be the output you are going to get? Same. Meaning that, so this from this point to this point, I can call it as memory location. Can I call it as memory location? Yes or no? Meaning that if I am going to give 0 as input, it is simply producing 0 as output, which means that this part I can call it as memory part. Memory part. I can represent the same thing in another manner. Can I call this as a kind of memory element where it can have, if I pass 1 as input, here it is you are going to get 0 as output, here you are going to get 0, here you are going to get 1, meaning that 1 you are going to get at the final, I can call it it's a kind of a memory element. So based on this thing, they constructed the next kind of memory elements. So basically we can able to implement the NOT gate with the help of NOR gate or not. Yes. So the same symbol I am going to represent with the help of NOR gate, because NOR and NAND are the universal gate, so I can able to construct it directly, right? So the modification for this one is I am using here simple NOR gate, and here I am trying to use one more NOR gate. if I am saying that this is Qn and this should be Qn bar, and try to observe. I have connected like this. Try to observe. It's a kind of memory element. It's a kind of memory element. I can call simply as latch, or I can call it as a flip flop, because it can able to store a 1 bit of information. How it will store 1 bit of information means, see, basically can I take this as A1 and I can take this as A0, right? How can you say that it is storing 1 bit of information? If I am going to give 0 as input, it need to produce 0 as output. If I am going to give 1 as input, it need to produce 1 as output, right? So how it will work? Try to observe. Is there any chance to start its debugging? How can we start? For example, I am assuming that here Q1 bar is 0. Sorry, Q1 is 0. If Q1 is 0, whatever its Q1 bar has to be compulsory 1, right? Meaning that here I am assumed that Q1 value is 0. Q1 value is 0. So definitely Q1 bar has to be 1. Q1 bar has to be 1, right? Now Q1 bar is 1, which means that, can I say that here you will get 1, right? Or else, if Q1 is 0, can I say that here it is 0? Yes, right? So for NOR gate, if I am going to give 0 as input, what is the output you are going to get? So this kind of representation is what? NOT gate only, right? See, this is NOT gate. This is NOT gate or not, right? If I am going to give X as input, X bar you are going to get. The same thing, right? If I am going to give 0 as input, what is 0 bar? 1. Is it satisfying our condition? Yes. Now this 1 is going to get 2 here. Now what is 1 complement? 0. Is it satisfying or not? Yes. Means at the first initial step I have given Q1 as 0. After some processing, what is Q1 plus 1? Same 0 only. Same 0 only. Right? That is what I am saying that. So if I say this is Q1 and this will be Q1 plus 1. Observe if you want. I have taken here 0. 0 will be coming here. What is 0 complement? 1. It is satisfied according to our requirement, because if I am saying that this is Q1, this should be Q1 bar. Q1 bar should be opposite to 0. So 1 is satisfied. Now this 1 will comes here. What is 1 complement? 0. Now 0 will comes here. Again processing, you are going to go 1 here and 1 here. 1 complement is 0. 0. 0 complement is 1. So if you are going to make it repeating n number of times, is it maintaining the state or not? If I am going to give 0, it is going to get 0 as output. If I am going to give 1 now, for example, try to give 1. If I give 1 here, what should be its complement? It should be compulsory 0, right? If it is 1, here you are going to get the value as 1. What is 1 complement? 0. 0. So is it satisfying our assumption or not? Yes. Now this 0 will comes here. What is 0 complement? 1. So if you are going to repeat this process, you are always going to maintain 1. If I am going to give 1 as input, I can get the 1 as output. So simply I can call this as locking of a variable. Meaning that if I am going to give 0 as a one particular variable value, the same 0 you are going to maintain without changing its value. I can call it as locking, or in other words I can call it as latch also. Latch means constant only. 0 means 0, 1 means 1. Right? So as this particular circuit is going to maintain two possible values, I can call this circuit as bistable vibrator or bistable element also. It can able to hold either 0 or 1 at a particular instant of time. Right? So we can simply call it as bistable vibrator. Guys, can I do the same thing with the help of NAND gate? Yes or no? Yes, we can do with the help of NAND gate also, because these two are universal gate, right? In place of this NOR, we can simply use NAND gates. Right? If I am taking that this is Qn and this will be Qn bar, and this will be connected like this. Okay, fine. If I am saying that this is A1 and A0, now try to make it solve. If I am assuming that Qn is 0, this should be 1. This should be 1, right? As Qn is 0, here we are going to get the 0. What is NAND operation of single input value 0? Not, right? So you are going to get the value satisfied. Now this 1 will come here. Single 1, if you are going to give input to the NAND gate, you are going to get 0. Which means that earlier we have given the input Qn, which is a 0, and for the next iteration also we are going to get 0 only. 0 only. Similarly, if I am going to give Qn as 1, this 1 will comes here. Obviously you are going to get 0, which is satisfied according to the rule of Qn bar, and this 0 will come here. 0 complement is 1, which is satisfied, meaning that if I am going to give 1 as input, it is going to produce 1 as output, right? So this one we can simply call it as a kind of memory element. A kind of memory element. Okay, fine. So basically, these two elements are these two kind of things I can call it as memory elements. Then what is the difference between these two, right? So basically, latch means it's also kind of a memory element which is going to store 1 bit of information. But the difference between these two is latch is going to be level triggering. Latch is going to be level triggering, whereas flip-flop is going to be edge triggering. Meaning that when a flip-flop is going to be work, if you are going to give either positive edge triggering or negative edge triggering, then only your flip-flops is going to be work. Whereas coming to latches, if you are going to give either positive level triggering or negative level triggering, then only they are going to be work. For the latch, if you are going to give edge triggering, is it work? No, it won't work. That's the difference between these two.